Unfortunately, today we don't have note sheets, mainly because the printer is still down. I don't know. It's kind of frustrating that the printers need internet to work. You can't just stick papers in and run copies at the moment. They're currently getting them to offline mode so that we can actually print without having to sign in. So in the meantime, we're going to have to take old school notes, paper, pencil, the whole way. Now with most of it, like these first few here, you do not need to write all of this down, because what we're doing today and starting today is applying transformations to a function. The two main ones that we have here are horizontal translation. So a horizontal translation, if we are applying a horizontal translation, we're going to use the general form of f of x minus h, where h is the movement left or right. So we plug in the value for h there and apply it to the function to see how it's going to move, or what our new function is going to be. So for your notes so far, horizontal translation are f of x minus h. This is our movement to the left or right. The other one we have is a vertical translation. It's our f of x plus k, where k is the amount that we move the function up or down. And we're going to use these general forms to be able to see how the functions are going to move or apply these transformations to them. Now, for the most part, there's not a whole lot of connection in just this here, how this works or how we apply it. So let's actually look at a problem and see how this works. So for this first problem here, one thing you'll need to have down is that f of x equals 2x plus 1. And that we're translating it 3 units down. We're moving the function 3 units down. So we want to write a new function that is a translation. We moved it down 3. And the new function we're going to call g of x. Now f of x, g of x, h of x, q of x, all of that is just a way to name it, so we know and can distinguish one function from another without actually having to physically point. We're talking about this function, not the other one. So our new function is going to be called g of x. We're just giving it a name. That's all we're doing. Questions on anything so far? Now, the way we're going to apply this transformation is using the general form. So we're talking about moving the function up or down. Here we're specifically saying down, which means we're using a vertical, or we're applying a vertical translation. And the general form for any vertical translation is f of x plus k. Doesn't have to be specifically f of x. We are just saying f of x to tell us and tell it this is the function we're applying it to. So if it had been g of x, we're going to use g of x. If we're applying it to q of x, we do q of x plus k. It's just a name. How far are we moving it? 3 units down, yes? So the value of k would be 3. It would be positive 3 if we're moving up 3, and it'd be negative 3 if we're moving down 3. So would this be positive or negative? Negative, because we're moving down. So we replace k with its value, the movement, down 3, so minus 3. If it had been up 3, we're going to put positive 3. We just write 3. Thank you. So now the other part we have is f of x. That's just our function, f of x. And we're told here that the function f of x is 2x plus 1. So we replace f of x with what it's equal to. Questions on how we got here? Now we just need to simplify. As we look at the 2x plus 1, is there anything in front of the parentheses? Any number, sign, term? No, so there's nothing we have to distribute through those parentheses. It's just going to stay 2x plus 1. Now the other part we have is plus negative 3. We don't write plus negative 3. We just write minus 3. Because if we plus a negative, that's the same as subtracting, so we're just going to say minus 3. Now, we can say we're done at this point as long as there are no like terms. There's nothing we can combine. Well, there's something we can combine, yes? Yeah. 1 minus 3, which is negative. That's it, because 2x and 2 are not like terms, so we can't combine it. So it tells us that our function is 2x minus 2. That's it. We've now moved the function down 3. Questions on any of this here? We ready for the next one? So our next function, you can write part B. The function is still going to be f of x equals 2x plus 1. But now we want to apply a transformation of translation 2 units to the left. Now they say they want a function h of x. The name really doesn't make a big difference in what we're doing. But again, it's just a name to tell us, or we can signify what is the new function. So we're going to call it h. Really doesn't matter what we call it, but we're going to give it a name. Now, since it's talking about left and right, we're talking about horizontal translation. General form for horizontal translation is f of x minus h, where h is our movement left or right. Now, looking at this here, we do need to plug in what the value of h is. And they told us we're moving 2 units to the left. So we know for certain h is going to be 2. Now, is it going to be positive 2 or negative 2? Because left is negative, yes? Now, again, you're saying, well, yesterday we talked about left and right's the opposite of what we think, yes? Left is indeed negative, but what do we have in here now? We have that negative, negative, yes? We don't leave it as a negative, negative. 2 negatives make a positive. So really what we're looking at is f of x plus 2. That opposite of what we think. Because it is negative, the movement is negative, but that other negative inside already makes it positive. So again, we're used to seeing left as negative. Well, and now it's plus 2. That negative, negative makes it positive. So especially when we're putting it in, if it's left, we're going to put it in as a negative of that number. If it's right, it's going to be a positive version of that number. But that means the negative in the formula is going to stay there. Questions on how we got f of x plus 2? Kind of sort of it. Left and right's a little weird, especially when describing it or plugging it in. It's a little different. But we feel good how we got here, yes? Okay. Now we need to figure out how this moves, how we apply it. They told us what the function f of x is, yes? F of x is 2x plus 1. Do I still have f of x? No, we have f of x plus 2, yes? Because what's inside the parentheses changed from what? x2 x plus 2. I've replaced this x with x plus 2, which means every x in the function has to be replaced with x plus 2. The 2 stays the same, but I don't have x anymore. We have x plus 2 plus 1. This is the exact same of what we just did here is the same as saying if we wanted to find or evaluate for f of 3. We replaced x with 3. So in the equation, we would say 2 times 3 plus 1. You don't have to write that down. What we just did with x plus 2 and here for f of 3 are the exact same thing. We're used to seeing it with numbers. We're not so much used to seeing it with expressions. That's all it's saying is we're plugging this in for x. That would be 7. Here we're plugging in x plus 2. Doesn't matter how many x's we have in the equation, all of them would have been replaced with x plus 2 with that expression. Questions on what we did? Yes, no? Kind of? Because when we have those parentheses, because this is, whatever's in here, we're replacing x with it. Because we're saying that this, really f of this here, this is really all we're looking at. F of whatever's in that spot is equal to 2 times that plus 1. So like with the one I just showed you, because we could say f of 3 is going to be 2 times 3 plus 1. Because what I put in for place of x is going to go in place of every x on the other side. Okay? Because we're kind of used to seeing this. It doesn't matter what I put in there. We could say f of y. F of y would be 2y plus 1. What goes in 1 has to go in all the x's on the other side. So for this here, when we said f of x plus 2, we're replacing and putting x plus 2 in every single one of those spots. And the last thing we have to do is just simplify. Since we have a 2 out in front of the parentheses, we're going to multiply through by 2. 2 times x is going to be 2x. 2 times 2 plus 4 plus 1. 4 and 1 are like terms. 4 plus 1 is 5. So our new function is 2x plus 5. It's our function when we move this 2 units to the left. Questions on this here? I can show you this here because starting function 2x plus 1 is this here. Our new function 2x plus 5, we can see that it did move to the left or up in a similar fashion. Questions on either one of these two problems that we've done so far? Okay. Let's look at some more of these here. So, first thing we'll need for sure is we need to write for a, we're using f of x equals 4x minus 9. In our translation that we're doing, we're translating it 5 units up. We're moving the function 5 units up. So our new function should be 5 units. The y value should be 5 higher than they previously were. And they said they want to name it g of x. Name doesn't really make a big difference, or is not that hugely important. We give the name to kind of help us identify what we are talking about. And again, with any of these transformations, I would keep coming back to the general form each time. So since we're talking about up-down vertical translation, it's going to be f of x plus k, where k is our movement up or down. What is our value of k? 5, yeah. Positive or negative? Positive because we're going up, negative if we go down. We still have f of x, yes? It's still x inside those parentheses. So that means that what f of x is equal to is still going to be 4x minus 9. I replaced f of x with its function, plugged in our value of k. Now we just need to simplify. Is there anything in front of our parentheses with 4x minus 9? No, so there's nothing I need to distribute through. There's nothing I need to multiply through. So the 4x is still going to be 4x. We're still going to have our negative 9. We still have 4x minus 9. Only thing in front of our 5 is our plus. So it's still just going to be plus 5. Are there like terms? Yes. The negative 9 and 5. Negative 9 plus 5 would be negative 4. That's it. Yes. No other like terms. So our new function is 4x minus 4. Questions on any of this here? Up, down is kind of nice. We're really, all we're doing is adding it or subtracting it from the function itself. And it is possible, because if we'd have moved this function up, say 9, our negative 9 plus 9 would be 0. So it'd just be 4x. That is completely possible. It is possible for that constant, that number, to just simplify out. Any question on moving this up 5? For the most part, I feel like our up-down is fine. The left and right is the one that normally is a little bit more difficult, or kind of a little bit more confusing on what we're doing, especially if we're not used to function notation. For whatever reason they wanted to call this h of x, name really doesn't matter. Now, since we're talking about a horizontal translation, we're moving left to right. The general form is f of x minus h. How far are we moving to the left or right? 1, yes? So we would have 1 in place of h, but we do need to figure out its sign. Would it be positive or negative 1? So the value of h would be positive because it's going right, yes? So we would plug in positive 1, just 1. But what do we have now? We have x minus 1. So that's still the opposite of what it looks like is still coming out. We're just having to plug in the correct sign with the value of h. So again, it's not one of those things that's over the top into it or complicated to it. It's one of those things we just got to pay attention. Because h here is positive 1. It doesn't look positive 1 once we get to this point, because now we have x minus 1, but the value of h is still positive 1. Questions on any of this so far? So the function we have now is f of x minus 1, yes? Now, it told us our original function f of x was 4x minus 9, yes? Now, for our f of x minus 1, we still have the 4, but instead of x, we have x minus 1 minus 9. Because all that's telling us that we're inputting x minus 1 into the function. It's our input value. Very much, especially as I kind of iterated on the last one we did left and right, we're so used to it being a number, a specific value, not being an expression. We can still do expressions. We ready to simplify? 4 times x is 4x. 4 times negative 1. Negative 4. Minus 9. Yes? We do have like terms, negative 4 and negative 9, yes? Negative 4 minus 9, it will still be negative, yes? What would it be? We can delve into, it would. Common Core, because Common Core, they did a whole bunch of things with 10, if you remember some of that. How far away is 9 from 10? How much more do I need to add to 9 to get to 10? 1, yes? Well, we're supposed to be adding 4, yes? So if 1 gives me 10, one of the 4 gives me 10, how much of the 4 do I have left? 3 plus 10 gives us that whole base 10 stuff, getting to the next 10, the next nice 0, that's all it was. So that we can add some of these numbers that aren't as nice to get to a nice number and then add the leftover to it. That's essentially making change. Count up to our numbers. Questions on this here? Would we agree that this is a lot and not a lot all at the same time? That's Algebra 2 in a nutshell. Any questions over anything we've done so far? Let's look at the next one. This one, you just need that. Because luckily they didn't give us a whole lot of extra words or extra description. F of x is 3x, and we want to translate it 5 units up. We want to move it up 5 units. All right? Did they give us a name for the new function? They didn't tell us we want to name it G or H or whatnot. So, well, give it one. Give me a letter. Doesn't matter. R. So our new function we're going to call R of x. That's just a name. The way I can distinguish it and f of x without having to point and tell you which one it is. That's the only reason for it. Okay. Translating it up 5 units. Vertical translation up and down is f of x plus k, where k is our movement. What is our value of k? 5. Positive or negative? Positive because we're moving up. Yes? F of x, we still just have f of x. Well, f of x is 3x. Pretty much because we have nothing in front of the parentheses for 3x, so it's still going to be 3x. There's nothing in front of the 5 except for that plus, so that's not going to change the sign. It's not going to change the value. So we still have plus 5, yes? Are 3x and 5 like terms? So the new function is 3x plus 5. That's it. That one's kind of nice. It's just we added 5 and we were done. There's nothing to combine, nothing to simplify. That is as simplified as it gets. Any other questions on this problem here? 1. Let's look at number 2. F of x equals the absolute value of x minus 3. And we want to translate it 4 units to the right. We'll use v of x because I believe I heard that earlier. Now our horizontal translation left or right, the general form is f of x minus h, where h is our movement to the left or to the right. How far are we moving? 4. So h would be 4. And since we're moving to the right, it would be positive 4 or negative 4? Positive 4 because we're moving right. But again, after we plug it in, we plug in that positive 4, we get the x minus h. We get that opposite. It starts looking opposite again. Now, just like with our last left-right movement, we've got to plug this in. We've got to simplify it. F of x minus 4. So every x in the original function has to be replaced with x minus 4. So the absolute value of x, that x is now going to be x minus 4. Telling us that we have the absolute value of x minus 4 minus 3. Is there any number in front of that parentheses after that absolute value? Well, no. So there's nothing we have to multiply through those parentheses. We don't have to simplify it. It's just going to stay the absolute value of x minus 4. Now at this point here, it feels like we have like terms between that negative 4 and minus 3. Yes? We cannot add or subtract through absolute values. We cannot move negative 3 in. We cannot move that negative 4 out. This is it. That's the nice thing with absolute values. We're not going to multiply through it. We're not going to divide through it. We're just going to leave whatever that is. If we multiplied it all by 2, if there was going to be a 2 in front, it would just stay in front of those absolute values. We wouldn't multiply again. Questions on any of this here? Questions on anything we've done so? We're going to move on to the next slide. Reflections in the x-axis, reflections in the y-axis. I'm going to stop here. We will pick this up tomorrow. Hopefully tomorrow we will have actual note sheets so you're not doing it on paper